From the relationship V equal to IR, we have said that it is a linear relationship. Increase in V will cause an increase in I according to our Ohm's law statement. Okay, now let us watch this. If I increase my potential difference across the ending, what is going to happen to the current flowing in the circuit, and at the same time the resistance offered by the conductor? All right, so let's see. An increase in volume, watch the I, in voltage, which is the potential difference. Watch the I. You notice that the I is increasing gradually, but the R is not increasing. See, an increase in V, the potential difference, cause an increase in I. A decrease cause also a decrease in I at the same time, but the resistance is constant. Okay, so let's see the relationship between the resistance and the current as well. If there is an increase in R, what is going to be the effect of it with the current that flows in the circuit? So an increase in resistance cause what? A decrease in the current. You see, as I increase the resistance, the current decrease, that is, I reduce. So if I reduce the resistance, you notice the current is increasing. All right, and if you watch from this material, if I increase the resistance, these spot particles, they increase on the material, that is, they cause a resistance in the flow of current. Okay, so increasing the resistance, you see the material increase. They are the materials that offer resistance to the flow of current. Increase in it will cause a decrease in the current, but the potential difference still remain the same. Okay, so that is what Ohm's law is all about, the relationship between the current flowing in a circuit and the potential difference at the two ends, provided what? Physical quantities are constant. Okay, so thank you. We are going to perform some calculation using this formula.